error-proof messaging, for example, as I understand it. And so they're doing some really good things in supply chain, boundary crossing things where you can trace from grain to glass if you're a distillery, for example. And so I just think they're really innovative and really novel. And I just thought that it'd be good to hear from them firsthand. So I hope I'm not overstating what the company is doing, but they seem to be doing great things.
No, you're spot on from a high level. I'm happy to give you guys a bit of a more of an introduction. Hopefully, I can answer most questions. If I understand, it's also a bit of a more technical crowd, so if there's some things I can't, I'll refer you to our CTO Vladimir, who had to step out last minute, so I'm stepping in. But I think I am well equipped probably to answer the majority of things you might have, and we also have Martina here on the call. She's our marketing and communications manager.
So how would y'all like to proceed? Is there a short few slides that you want to present on background before we have a discussion? Is there a demo that you might have available?
Have both of those things available. Just remind me quickly, how much time do we have so that I know to adjust the.
We've got the hour, so we'll be ending
Okay.
on the next half hour.
Okay, then maybe maybe I can share a couple of slides, just guide you through the concepts of what we're working with, give you some concrete examples, maybe also just show you a quick demo of how this looks like in practice, and then I'm happy to have a conversation discussion around this.
Super.
And I'm going to go ahead and record if that's all right with you guys for the folks that can't make it. So.
Yeah, definitely fine.
Great.
Just quickly pull up the screen and let me know when you guys can see it.
Got it.
Yep, looks good.
All right, fantastic. So I'll just do a quick introduction into the decentralized knowledge graph and kind of the key things, the key concept around knowledge assets, which are really the things that you'll be most interested in. And just to start with that, give you some characteristics that each of these knowledge assets that are essentially well, I'll actually go into that in the next slide, but start with this, which we consider them as a new resource for the internet. It's a new way of exchanging knowledge between organizations, individuals, and having that done with a connected semantic web approach in mind, as was mentioned, someone mentioned before. And some of these characteristics that the knowledge assets that that we're going to look into have is that they're ownable. So there is a body of knowledge that it's a structured knowledge. That's each of those is represented by NFT that can also be transferred as a means of transferring ownership. They're discoverable. So we introduced the new concept akin to the URL in the Web2 world called the unique asset locator. So each asset will have its own UAL to be discoverable and found, so it can be found on the decentralized knowledge graph. They have integrity. So each knowledge asset has a verifiable issuer and data state on the blockchain. Meaning that you can always be certain that some particular entity, particular organization, particular individual issued the body of knowledge that you are actually looking at. And also that what you're looking at also is represented with a digital fingerprint on the blockchain, meaning that you can verify the data state, that nobody tampered with the data, and so on. There's the data privacy. So each knowledge asset has a certain amount of metadata and indexing data that you would require to put them as public information, but that's also very flexible. But everything else around it can be made private depending on the use case that we have, and we work with some very sensitive data has proven to work quite well. They're structured. This is the semantic web approach. All of them have their own knowledge graph, they're RDF and Sparkle compliant, and it can be also a various number of different standards can be applied, and we do apply them as well. We'll show a couple of other examples later down the road. And they're composable. That's one's also very important, meaning that you can connect one asset to a number of other knowledge assets that are related to to it. So that means you can, especially we talked about, or somebody mentioned supply chain before, you can really connect different pieces of the puzzle across organizations together to get a whole pictures. But supply chain is just one of the examples that is maybe the easiest to comprehend that composability with. And all of these characteristics that we have here, we've also started working on AI. It really makes them AI great, meaning that as these things, as knowledge assets get created, get connected, they're also ready to power AI-enhanced search and applications, such going in the direction of course, our vision is going in the direction of ChatGPT and the likes, but using a much more solid and trusted and verifiable foundation of data that can also be encompass private data, not only the public one. So that's just kind of an overview of their characteristics, but how do they actually look like? What is the anatomy of a knowledge asset? Well, we have the asset graph, which is the RDF, W3C RDF format. So standardized knowledge graph format also can be queried with Sparkle queries, as any other knowledge graph could be. And this can be really anything, right? This is where the knowledge is contained. So it can be in context of supply chain. It can be a group of supply chain events that happen. It could be a business, an asset that describes a business location. It could be a certificate that someone issued for an organization, for an individual, or for a specific location as well. It can be a list of transactions, financial transactions that you're looking at, geographic parameters. For example, that's what we do a lot with some of the products that contain geographic risk parameters for a certain country or a specific region in a country. So all of these types of things, anything you can imagine, anything can be used in the knowledge asset as a body of knowledge. But that's the data part. And then we have the unique asset locator part. So each of the knowledge assets will have their own UAL. And of course, then what I mentioned, we have the immutability proof. So that's where the blockchain layer comes in, and the ownership record, which is an NFT. So essentially, once you create this asset, this is how it looks like, and this is what lives on the decentralized knowledge graph. And there are a couple of operations that key operations that you can do with the knowledge graph, with the knowledge asset. So we can create knowledge assets on the graph. We can resolve them, right? So based on the UAL, get the knowledge assets from the graph. They can also be updated as an issue, as the owner of the knowledge graph. You can also update the asset graph if that's what's needed. And of course, they can, in terms of that ownership record, they can also be transferred to a new owner. This is very interesting in situations where we have, in supply chains, for example, chain of custody and the likes, where maybe ownership of, for example, trade documents is very important. So you can see who has what at one point in time. So that's the overall concept and the anatomy of how it looks like. Very conceptual. So I would go into one more slide and then show this how this looks like very concretely. I mentioned before the decentralized knowledge graph. The decentralized knowledge graph is where these knowledge assets live and where they can be discovered and it can be connected. And the decentralized knowledge graph, let me just put a laser pointer so it's easier to see. So we have the decentralized knowledge graph, what we looked at before. So this is where the knowledge assets live, and then we have the consensus layer, which is blockchain, and the graph is multi-blockchain, so it can connect to multiple blockchains. If you guys are interested in that, we can talk about it in the discussion. I have a separate slide kind of showcasing how that works. But we have that blockchain layer, we have the knowledge graph layer where the knowledge assets live, and then we have applications that might be using them. And this is where different businesses, different organizations would have different applications that essentially consume a network of knowledge assets for different purposes, be it ranging from supply chain traceability to we're doing a lot now in construction, so to see building, for example, data, and then what the certificates are and what the materials are and all of these types of things. So it's the application layer is really like a blank piece of paper that can be molded based on what a certain organization requires. And just going through this, I mentioned already it's a multi-blockchain decentralized knowledge graph. So there's one graph. It's a open source architecture that is hosted on the OriginTrail decentralized network, and that one can connect. So there is one knowledge graph that can connect and use multiple blockchains simultaneously. So it's not individual instances, but the graph itself is designed in a way that gives users the freedom to choose the blockchain that they want, and that's pretty much kind of conceptually how everything runs. Now, how this looks like in real life, for example, this is a web of connected knowledge assets in a very simple supply chain setting. Now, each of these bullets, each of these dots, imagine are one of these knowledge assets that we just looked at, and they're color coded differently because they can come from different issuers, right? So imagine the purple ones, they come from a shipper that ships something with a logistics provider that might issue some of these in yellow, and then the green ones, for example, are the receiver of a logistics package that all have different systems, different ways of operating, but through issuing of these knowledge assets, all of these can be connected together. And here you can see we have a couple of supply chain events where they point to some business location where this supply chain event happened. They point to the product lot that was involved in the event, and of course the product master data. A shipping container where this was all aggregated, some IoT readings that the shipping container captured while it was on the way, and then receiving again at a separate business location. So that's how you get this end-to-end view, even though all of these knowledge assets might come from different players in the supply chain. And all of these might, aside from the RDF, right, they also use different global data standards that are domain specific. For example, when we're talking about supply chain events, all of these assets, and we can look at a couple in the system later, they use, for example, GS1 EPCIS data standard, which is the global data standard for recording supply chain events. And the product lots, they use GS1 standard for describing lots in product master data. Business locations, the same story. So it's really, you can apply a variety of different standards depending on the domain, depending on the use case, to build these knowledge assets. And then because they are so interoperable, they can also be consumed not only by new applications, but also by existing systems. So we have a couple of cases where the knowledge assets, for example, are consumed by SAP to pull everything in and have an interface there for the user. So just one last slide that I have, which is on the network operating system. So we looked at the knowledge assets. We said that they live on the OriginTrail decentralized knowledge graph, but somehow, Alan, I see you raise your hand. I'll stop here. Just maybe.
Oh no, I was just gonna. I can wait till you're done with the slide deck. I just wanted to get in line here.
Okay, gotcha. It's just one more slide, I think, and then
okay.
we can stop you answer some questions before the demo.
Okay.
But yeah, we mentioned that the OriginTrail knowledge assets, what they are, how they look like, how they're connected in practice. They live on the OriginTrail decentralized knowledge graph. But how do they get there, right? So you need to create them from something. And what usually happens that there is a whole bunch of data that already exists in different source systems across different organizations that is in one form or the other, but it's not, usually it's in silos, it's not structured, it's not verifiable, and we somehow need to get the data from those source systems to transform them into knowledge assets in the decentralized knowledge graph. And this is where we have actually a proprietary piece of software. The OriginTrail DKG is open source that helps essentially with this transition. So the network operating system has a bunch of tools for ingesting data, creating assets, and then helping you also query the assets that exist on the OriginTrail decentralized knowledge graph, so that you can then build solutions on top that consume these knowledge assets. And here I mentioned just a couple of those, where I actually have this slide just that describes what was on top. We do a lot of work in the, as you already mentioned, in supply chain and trade and trade risk, essentially. So that's where Trusted Factory, where we work with the British Standards Institution and the SCAN organization, is very, very cool. They are using it essentially to create knowledge assets from security audits of different factories across Asia. They have over 25,000, and they cover over 40% of US imports, those factories. So it's a very cool example because those certificates, those audits are actually required to be for them to be allowed to be imported into the US. We then have rail travel safety, where we work with the SBB Swiss Railways, where they are actually using this as a decentralized EPCIS repository where they can track every piece of material that comes in, what happened to it, that can be then used for predictive maintenance and analytics and ensuring that their systems run safely. We have a variety of things also in food and beverage. I think Alan, you mentioned one before around the whiskey distillery. That's a really cool one because it's a startup distillery that started from scratch, and they essentially everything from their grain to all the way down to bottling is created as knowledge assets, and it can be on the one hand consumed by the customer that bought a bottle of whiskey. Through a very nice visual interface, they can see what the whiskey is from all the way down to the grain that went into it, and everything that happened in between. But also from this tokenization point of view, because each bottle and each cask is automatically created as an ownership token that we can play around with that angle as well. And then last thing I would mention, which is definitely not the least, we work a lot in the pharmaceutical sector as well, specifically also with the British Standards Institution, and we worked a lot in the donated medicine space, where usually it's a bit of a black hole, since when manufacturers donate something to an NGO that then has to distribute the medicine and products to low and middle income countries usually. You can imagine that systems in those countries are lacking or not existing. So what we did there was enable this World Federation of Hemophilia, which distributes a significant amount of donated medicine every year, to actually prove for every vial that is donated where it ended up. And we did this by connecting systems through NOS to create these knowledge assets, but also developed a small, very handy application to fill in the holes where the systems are non-existent for the users to actually scan the vial that they're administrating to a patient. And all of this connected them to an interface that these guys can look into and say, okay, there's a problem here. This is what we should investigate. But yeah, so I've done a lot of talking now, so I'll stop. And Alan, I think you were the first one to raise the hand, so I'll let you kick off the conversation.
Well, it's a really good story, Yuri, and I'm just wondering where the bottlenecks might be that you've encountered. And for example, the operating system and the creation of the knowledge assets. It seems like working with a lot of established companies who are used to doing things a certain way, all of a sudden creating these knowledge assets so that they're interoperable might be a bottleneck. Are you having the resources to be able to do what you're doing, or are the customers, the suppliers, able to sort of navigate the learning curve?
Yeah, that's a very good question. So bottlenecks, I see you mean more from a business angle rather than a tech angle itself, right?
Right.
Yeah, so you have different industries that have completely different levels of maturity, right? So if I contrast, for example, pharmaceuticals, they are very ready for this because all of the GS1 identifiers, markings, everything is mandated legally for a while now. So every pack needs to have a data matrix code that contains the G10 identifiers, the lot numbers, the serial numbers. So they're a lot more mature also in terms of them being able to create knowledge assets that record events and all of these things. If I compare it to food and beverage traceability, for example, they are a lot less mature in that sense. So a lot of the input comes even in an Excel format, right? And we need to transform an Excel format coming from a farmer, for example, into a JSON LD knowledge asset, right? That essentially gets created on the graph and connected to everything else. But this is where the network operating system here has a lot of flexibility, because we have the data ingestion and the data pipelines behind it. We have a lot of flexibility in terms of how we do it. So you can really upload an Excel manually and create a knowledge asset based on a defined pipeline that you need, that we help you build sometimes, but there are also some default ones in there. And then you have more advanced, for example, cases such as the training certificates, pharmaceuticals, A-Trust, where we get actually JSON LD files already via API. And then we create knowledge assets based on certain rules, that business rules that need to be applied to get what the customer really wants. So it depends really on the industry, is a short answer. But there are definitely cases where you can set them up a lot quicker than the others. And this is really why we developed the network operating system, to help with this, because it really gives all of that flexibility to start doing this very quickly. So you don't have to also deal with the companies, like you said, they're set on dealing with certain we're doing things in a certain way. A lot of them still very let's say cautious around, when it comes to tokenization, having to deal with tokens and nodes and whatnot. So the NOS really takes all of that complexity away and allows them to operate in the, let's say, established processes, whereas under the hood all of these things are taken care of, right? So tokens, wallets, identities, everything is kind of abstracted by the NOS.
Yeah. Makes good sense, at least from a storytelling perspective, and I'm sure the devil's in the details sometimes.
Always.
Yeah. So the other question I had, I'm wondering if you had a nice way of describing how access control happens in a decentralized environment. And I've read some about IPFS, for example, and P2P data networks. And I'm wondering, is there a way you can tell the rest of us how you're doing that access control? And is it somewhat, are you able to take advantage of the content addressing of these peer-to-peer networks in the process?
Yeah, so I can give you probably a high-level answer to this. That probably for detailed one, very detailed, I will be a bit out of my depth. But there are a couple of ways we handle data access control. One of the simplest way is that, for example, if we have so Scan is a great example. They have a knowledge asset vault where they keep all of their knowledge assets. Essentially, they're all private, right? Nothing is public aside from the indexing data. And only their application, which is called the Connect Screen, only that has access to the knowledge asset vault. And they handle the permissions, right, then on an application level, if you will, not on the protocol, on the node level. So that's the simplest way. And then we can go or we have also then obviously on the node level, if you will, where the knowledge asset vault level, permissions can be set by whitelisting IPs. So that's one way to do it, to just have access to the entire knowledge vault. Or more granular details that are also working in combination then with partially with decentralized identities, right? So if you have you can say that this asset can be accessed, the private component of this asset can be accessed by the decentralized identities X, Y, and Z. And then if you query with those identities, we have the public and private keys, right, to verify that you are in fact the owner of that wallet. Essentially, it's a wallet, it's a pair of keys. You are able to access this. And then we have the more innovative way of doing it, which are access tokens. Where you can generate a data access token, for example. It can even be timed to say a person who holds this token, right, can look and read this knowledge asset for, I don't know, a week or something, can get access to it. So those are the ways, kind of the main ways. I'm hoping I didn't say something extremely inaccurate. I don't think I did, but it really depends then on how the customers want to implement this, right?
Yeah, understood. It sounds like there are lots of options you can take advantage of, and depends on the circumstance.
Absolutely, yeah. It's if you look at this layer here, right, the decentralized knowledge graph where the assets live. We try to do this because this is also it's an open source software, right? We try to keep that layer as flexible and as open as possible for users to use the way that they feel is right? So that component is completely as open as possible. Whereas then with we define with different applications, different use cases, more specifically how certain things should look like. Right.
Thanks.
Cool. Does anyone else have, did anyone else want to ask any questions, or should I just do a quick demo of how these assets actually look like? And Dave, go ahead.
Yeah, I'll do a quick one. So several people on the call are from semantic arts, and what we do is mostly knowledge graphs for enterprises. But we've always been fascinated at this, knowledge graph between enterprises, which I think is sort of what your sweet spot is. But obviously, your stuff has to get back into the enterprise. They have to actually integrate it with the rest of their systems and their graphs and all that kind of stuff. Any thoughts on, I guess, how we would connect up with you, if we're in a client helping them turn their internal systems into a knowledge graph, do you have an ontology for this, and how would we align what we're doing with that, things like that?
Yeah, that's a very good question. And in terms of ontologies, it would also depend on what the use case is, right? So in the context of, for example, like what we looked at for supply chains, we use heavily GS1 ontologies and standards. So anything from the EPCIS 2.0 standard for supply chain events to the global location number standard for describing business locations, to global data model for describing product master data, and a couple of others. So we have that. For construction, it's a completely different set of ontologies, for example, that we're working on now together with a bunch of industry and the institutional partners as part of a European funded project called BuildChain. So there, for example, a completely different set of ontologies would apply.
Yep.
But that's kind of in terms of then helping to answer your question, in terms of helping you connect, because that's always the question: how do you connect these things? Because all of these things that we create with customers are, they have some data standard, global data standard applied to them. If it's a trade document, it would be an e-bill of lading or an ECMR standard or whatever is needed. Because that's the case, it's very easy for systems that can read these standards to consume the knowledge assets. So we have, for example, with the Swiss railways, they consume it in their system all the time because it's all they're looking for EPCIS structured data. So as the knowledge asset is created, they get all of the benefits of it being verifiable, it being connected to other relevant assets and objects in the graph. But at the same time, it can be very easily consumed because of that interoperability. So the system knows what to do with it, right?
Yeah, cool. And where are you based? Are you based in Europe?
Yeah, so we have an office in Slovenia, we have an office in Belgrade, we have an office in the UK. So I am currently in the US, so it's time-wise a bit easier for me. But yeah, we are based in Europe, but a lot of our business is also here in the US, particularly with SCAN is, for example, this is a US organization. It's called the Supplier Compliance Audit Network. So it's an organization of the largest retailers in the US, like Walt Disney, Walmart, Target, Costco, all of these guys. So we do a lot of work in the US and a lot of work in the EU. Those are our primary markets right now. And I see another hand was raised.
Yep, Peter.
Meanwhile.
Yeah.
Hey, Peter, go ahead.
Peter Campbell in Brussels. Do you have any use cases in the power systems industry? High power transmission and those kind of industries. I'm just curious.
We don't have that specific industry, but our partner, so we do a lot of these solutions because obviously we're not the domain expert, we're the tech expert. So a lot of these solutions that we build, that we do together with the British Standards Institution, which are involved in pretty much every industry you can think of. So they are the ones, when we enter a new industry, usually they are the ones that help us with that, say, industry specifics, understanding what's important, how it works, what standards and all that stuff. But we don't have a specific case on that yet. But it doesn't mean that we're not open to it, of course.
Okay. All right. Thanks.
Does anyone else have a question? I can also hop into the demo quickly just to show how some of these assets really look like on the graph.
Yeah, I think a quick demo looks good.
Yeah.
All right, cool. Then let me just reshare the screen. I need to share a different one. So what I'm going to show you is really a demo of the network operating system, but it's the prototype version of it, if you will, or the beta version of it. As we're releasing a new NOS in the next couple of weeks, month, but it serves the purpose well, I think, to show you guys how it works. Let me just find the right screen. Is it this? Oops. Yes. All right. So let me know when you can see the screen.
Yep, looks good.
Okay, cool. So here we have the knowledge asset vault for a demo project that I've created, and I've created a kind of a simple connect. Essentially, what we looked at before on the slide where you saw the connected different supply chain events and all that stuff. So I created that as just for demo purposes here. So what I'm going to do is I'm going to load an asset that is essentially a supply chain event, and just show you how that then connects to all of the other assets, how it looks like in graph form. Now the visualizer is cool to show. It's not in the best format right now to read and explore everything, so that's one of the main improvements. But I think it's very cool to see how the assets actually look like when they're connected and all these things. So you can see the dark blue dots, their assets. You can see also the at ID of the asset and the UAL. And you can see that this one is a supply chain event. So we can see, let me zoom in just a little bit more. So we can see here in the event list, what is the event about. So it's about an aggregation event that where we have a parent ID and a child quantity list. For this in GS1 terms mean we have a container in which these particular products were stuffed into, right? So we see 150 pieces of this product with this slot and 100 pieces of this product with this slot, and that's the event itself. And if we go up here, we see that the event is connected to a bunch of other knowledge assets. For example, let me find one that is a location. This is a location. You can tell by the ID because it has an SGLN. And I had this issue last time as well. As soon as I share the screen, I can't click. So let me just do one thing. I'll stop sharing and I'll reshare as soon as I open it. Yep, I have no idea why that's the case. I think when you share the, the window only, that's what happens. But I'll share the full screen now so you guys can see. Is it back up? Can you guys see the screen again?
Yes, you can see.
Yes,
Okay.
looks good.
Yeah.
Cool. Okay, so now we open. So this was the event, right? The event was connected to a business location where this event transpired. And here we can see that this, what the details, metadata about this location. We can see the location description, the location name, what the address is, the country, and also, for example, in this case, who the location, which organization it's owned by, and all these things. And then you can also see another asset that it's connected to is a product, the product that it was being packed in that container. And then you can open that and see the description essentially of that container. Sorry, not the container, the product. So you can see this is a product that has a GTIN number this, it has an expiration date of this, it has a lot number of this, and you can see that this one is then connected to the SGTIN, which is the product, the overall product master data. So if I open this, I get the full, as you'll see, master data around that product. So, and this is how then you can compose, that's the composability aspect of it. And here we see that this is the SGTIN, and you can see that the product name is brand name Sunny Tabs, it's chewable vitamin D tablets. They have a net content of 50 in each pack, and then they weigh 100 grams, and they're meant for this target market here, which is in the UK. So this is, and then if I zoom out now, right, you get then the idea of that composability. So the assets are just, you can just continuously expand and connect. And if somebody was to query for what happened to a specific lot of the product, they would get this event, and they would get all of the subsequent events, also the event around, and let me see if I can open that one, the container, which is where the product was stuffed into, and you get information around the container. And then the container is connected to the IoT readings that happened as it was in transit, and so on and so forth. So this is really kind of, and on a highest of levels, showing how the power of composability, and all of these can come from, in this case, I created them, but all of these can come from, can be created by different players, participants in the supply chain, and of course have different viewing rights as well, if they're not allowed to see certain parts of the asset network. So yeah, here you can see that this is a container. It's a 45 code. This is, according to the standard, is a 40-foot container, and then it's connected to, yeah, I think this is the one with the IoT data. So that's how it works. I just keep clicking and expanding and giving some more context. But yeah, this one was, for example, that was the event with the IoT data. So you can see here that we have a event list that is connected to a sensor element that tells us, okay, the unit of measurement is Celsius temperature. It was 17.2 mean values, 19.8 max, and minimum value of 15.5. So you get this network of connected knowledge assets across your business network, essentially, or anywhere else, that can just keep on growing. And once the applications have access to all of this highly structured data, they can be used for anything, right? We use in HTrust, we use it for a variety of dashboards, for example, to show how much product went into a certain location, how much went out, where was the product administered, was it at the right location to what patient exactly? All of these things, become part of this asset network, if you will. And yeah, I see Chris raise the hand. Go ahead.
Okay, so the question really is how do you define the boundaries of the knowledge assets, given that knowledge tends to be kind of a bit of an amorphous thing, everything's connected to everything else. You've got clear divisions between the assets. Is this done by a modeling activity, or do you feel it just emerges naturally, or how does it work?
It emerges, like you said, a little bit, because you can obviously model the assets also in a very number of different ways, right? So you can also say, I don't need to have a business location as a separate knowledge asset. I can, contain it in another one. So it really depends case by case. And what we found, we have a very good feel of, for example, in supply chains, what needs to be its own knowledge assets, what doesn't need. For example, there's no need for each supply chain event to be a knowledge asset, right? Because the way the standard is also defined, you have a list of events that you can package up in one object, essentially, and they all have their own identifiers. You can package that up in one knowledge asset and search for it within. Whereas we found for products and locations, that's much better. In product master data, it's much better for them to be their own assets, because they also can then be very easily accessed by, for example, product master data is often needs to be accessed by retailers that are buying the product, right? So that they can display it on to their customers and all these things. And then it becomes easier, because you can say, okay, these guys have access to the entire knowledge asset. I don't need to complicate things around there. Oh yeah.
So it sounds like you have a set of principles and ground rules, which take a bit of expertise to apply.
And it's all, I mean, this is bleeding edge technology, right? This is, we have a bunch of these things implemented. With the knowledge asset concept was born already a year ago, but the network that starts holding it and all of the stuff that then we transformed into this was only launched in December. And since then, we have seen so much improvement in the way that the implementations that we have done are actually running, and a lot of feedback where we've already made a couple of improvements. And the concept just feels that it's naturally understood also by the customers that we speak to. So it seems like it's a good
Yeah, it's a very impressive concept, I think. Very impressive.
Thank you. Yeah, but that's what I have for the demo. So happy to have more of a discussion if you guys have more questions. If I didn't answer something satisfactorily, I can also, from a tech perspective, I can also take those questions and then get back to you with some more input from our more technical minded people. But I do have relatively okay insight also in the tech.
Well, Yuri, you've talked a lot about the standards, and I was just wondering, there was a group in the UK led by one of the semantic web gurus at the University of Southampton, and what they seem to be trying to do, this is a couple of years ago now, was to align these tiers of data standards that have evolved over the years. And I don't know if you've come across those folks or if they have some interaction with the British Standards Institute, but it seems like it's called? I thought it was the Genesis Project, but they've got another name for themselves. That's a 4-letter abbreviation. I'd have to look it up. I can share it later. Doesn't have to be. I mean, I can just follow up later.
Happy to have a look. But it's when it comes to standards, right? It's also you have standards when it comes to data standards, right? Which is what we are kind of mostly involved into, data standards, ontologies, and all these things. With BSI, it's also a lot about, say, management standards, specification standards, and all these types of things, which are also very important in a sense. We're doing a for example, very interesting experiment or an experiment proof of concept with them, which I'll hopefully be able to talk more about in the next weeks, which involves then running a fully AI, not fully, but AI enhanced semantic search across these knowledge assets to return values or to return insights for somebody, for example, who's designing a product and needs insights around the standards and whatnot, right? So turning standards into semantically kind of enriched knowledge graph representations, which is as much as I can say at this point, but it's a very, very exciting piece of project that we'll probably be able to talk more about in the next weeks. So, and that also, it relies on standards on one hand, being that those management standards being available in that representation in the graph, but it also relies on data standards so that you can extract information and so standards and ontologies, right? So that you can extract information probably from what you're looking for. So it's a very interesting kind of, we work with a lot of standards bodies. So we also have been part of the GS1 EPCIS 2.0 standard specification working group. So that one we're all GS1 standards we're super familiar with. And obviously the base standard for knowledge graph here is the RDF. Everything is in RDF, represented in RDF format, and can also be queried with Sparkle, and then different ontologies come in with different use cases. Yeah, that's I guess the wrap up.
Thank you. Chris, you had another question?
Sort of really general question, or you're talking about standards. Do you see this ultimately, it's probably a bit premature yet, but do you see this concept being the basis of a set of standards over the future?
It definitely could be. It's kind of like I said, the knowledge assets as a concept were born a while ago, but they have really just come to life in the past, let's say 3-4 months, and we're still learning a lot. But a lot of production cases are already running on it, which is where we're learning a lot, I guess. And maybe it will, like you asked a couple of relevant questions around how, how do you know how to package, what to package in a knowledge asset, how to do it. So maybe there is also, sometime in the future, a set of standards that help guide this this type of thinking
Right.
for the
I mean,
user.
I would have
Yeah.
thought that was more of a best practice thing. I'm thinking more in terms of standards of how the blockchain is related to the knowledge assets. I mean, assuming that there is going to be more than one supplier of this kind of system, and that you want those suppliers' products to be able to interwork, maybe you need some kind of standards so that
Okay. I
specialist
see what you mean. Yeah.
blockchain people can do their stuff, and specialist knowledge graph people can do their stuff, and they can interwork.
Yeah, that's a good point. And actually, maybe let me see if I can pull up one slide, because just to make it very plastic and clear. So we have, yeah. So this whole multi-blockchain configuration works is like this. There's one decentralized knowledge graph where all of the knowledge assets live, and it doesn't matter whether the knowledge asset uses the underlying blockchain A, B, C, D, or F. They all have the same. When you're looking at them from a knowledge graph perspective, you can query them just the same way, access them just the same way. There might be some functionalities on the blockchain level around NFTs and smart contracts that might differ in terms of that. That's something that is being developed. That's why we actually once we migrated now from the version 5 network, which has been live for quite a number of years, to version 6, it was a breaking change in that sense. It's a completely different technology, so it's a separate network. And for now, that network runs on the parachain, essentially, that is plugged into Polkadot, that we built that to serve the decentralized knowledge graph most customized, if you will, to have the most functionalities. But it has all of the, so as we now go along, we'll be adding, based on certain criteria, of course, accepting also other blockchains to access the power of the knowledge graph. So that on the version 5, for example, we had Ethereum, we had Polygon, we had XDAI, and now we have Polkadot here. So
Okay.
it's
right.
a very
But
interoperable
I see you're talking about specific implementations rather than here's a standard, and if they conform to it, we'll work with them.
Yeah, that's something that we're still working on in that sense, because that's a very fair point.
It's maybe premature. It takes a long time for standards to evolve.
It's true, but it's a fair point. It is something that we look at it as a set of criteria, right? That can be at one point in time packaged in a standard that is more comprehensive, if you will, in that sense, and easy to follow. But yeah, this is how it looks like from a, let's say, multi-blockchain perspective. It's one knowledge graph, different blockchains, but all of the assets, doesn't matter what blockchain they're on, they have the same, they work in the same fashion.
And on the semantic level, you're using the W3C standards, and they apply, if you like, a standardized way of interpreting the different knowledge graphs.
Yeah, there's really, so you mean the knowledge graphs within the assets themselves? Because there's only one, the network, right? This is a separate, think of this as, or not think of it, this is a separate network of nodes. So it's not the people running the blockchain nodes have nothing to do. They don't hold the data. They don't hold the index of the knowledge assets. This is a separate network of nodes that is run, that you can run it, right? It's an open source configuration, so anyone can run it, and they get compensated for storing and indexing those knowledge assets on the network.
Okay.
So it's a two-layered network, right? You have multiple chains and then one separate network,
Right.
which is the
Which is
decentralized
at the
knowledge.
top.
Yeah.
Sorry, I don't want to monopolize all the questions. I'm just very interested in it.
No, it's a fair question because it's often it's also immediately then okay, it's multiple blockchains mean there's multiple knowledge graphs, right? That would be the sensible logic, but it's actually one knowledge graph that one network of nodes that runs the knowledge graph. And if you run a
Right.
node, you can connect to all 4 or 5 blockchains at once and say, I want to listen to offers, right, for storing knowledge assets from all of the networks. It's fine. That's how the nodes actually work.
So does that top level network, does that is that defined, say, by RDF with the UALs as objects? Yeah. Okay.
Yeah, correct. But on the blockchain level, that UAL gets kind of translated into an NFT that is tied to that UAL as an ownership token, right? So you can think about it as if you now buy a I know that they do it a lot now with watches and cars, right? You get an NFT, but think of it this way: you get an NFT. It's not just an NFT on a blockchain, but it's an NFT that holds a body of knowledge through
Right.
these knowledge assets, right? That can also grow. And can be extended, and you can grow it. If you own, for example, the knowledge asset of the car, you can then connect different knowledge assets to it and say, this car has been driven by, I don't know, celebrity XYZ, and that will increase the value maybe. I don't know. I'm just kind of talking off the top of my head, but that's how collectibles usually work, right? So it's that part is more, let's say, the whole metaverse piece is we have quite some community members that are very interested in it and they're building some stuff on it. But it also really just works as an ownership token that is not only just a token that says, okay, I have some number of strings on a blockchain, but it's connected to a body of knowledge that tells you stuff about it, right? The same
So
with the whiskey.
does it basically incorporate a digest of the knowledge, so that so that you have a guarantee that the knowledge is what the token is about?
Yeah, it's also now going into into more details around it, because you can also create mutable and immutable assets, meaning that you can create assets as an owner that nobody, even if you create them, you can't update them if you don't. And that's very important for scenarios like when you're handing out certificates, for example, right? You hand out a certificate as a national, let's say, certification body. You hand it out, somebody else becomes the owner of that certificate. If it was a mutable asset, they could just update it, right? But in this case, you issue it as an immutable asset, meaning that's your certificate. It's valid in that form. If you then want to update it, you can have another asset that points to it, and there's different ways of building it. But like we said before, the devil's in the details and how you want to play around and how you want to build a certain use case.
Doug Beeson's got a question.
Hi, thanks. Yeah, this is a really terrifically interesting product. I was wondering if you guys have explored the intersection with the solid pods, because you were mentioning NFTs, and I'm thinking like, oh, this is like data that you could want to belong to you, or possibly you want to even put yourself into a bit of a knowledge asset. We could have our ontologists as knowledge assets, Dave.
Yeah, you could. Yeah. But I don't think we have. I don't think we have experimented. This is kind of a new architecture on this new network where, the NFTs are automatically, as you create a knowledge asset, right? The knowledge asset by the default has that NFT as its a kind of integral part of it. But I'm sure on that angle also things will evolve, because now this is a basic concept, right? There's a lot of things you can do with NFTs and different you have these nested NFT concepts and whatnot, right? So I think here we're only also just starting to scratch the surface of how to best use those things as a effective means of also interacting with knowledge, ownership, all of these components that will come, I guess, in the next weeks and months to the surface more and more.
I mean, you guys are already non-fungible, so we don't really need to tokenize you.
That's very good. Thanks for the yeah. It is a we are a pretty unique project in that sense, and what I think is the most because I also come from a supply chain background. I worked in consulting, supply chain consulting for 5 years before I joined the company here, and that was already also 5 years ago. So I've been here a while. But the whole point is that we learned all of these things based on actual implementation. You know, we started with something, but then we just started working with different organizations, and we got so much feedback from the real world, right, from real users, that really led to I think this version 6 culmination. That is it's really, I think already now we're getting so much value out of it that I firmly believe that we're only scratching the surface of what it can do.
Do you have some sort of way that our clients could sort of try this? You know, is there a try before you buy kind of thing?
We have so for the network operating system, we will release soon the new version that will might have some of these components. Yes, for the network itself, you can play around. It's open source. All the documentation is available. I can send you the link. You can play around already now. It's free for everyone. There's a test net, right, where we can play around with this without actually spending any money. There's a faucet for testnet tokens. So I can send you that documentation, and then for the NOS, which is the streamlined version for enterprises, we're going to be releasing some new stuff in the next month or so. Yeah.
Okay.
So the NOS is what I showed you the assets in, and there's some other exciting stuff coming. So in the next month, so keep an eye out, or I can send you some things as they come out.
Yep.
I think somebody else had their hand up. I'm not sure if.
I don't think so now. Oh, yeah.
No? Okay.
Martina dropped some documentation in the chat. I dropped the website in there as well for anyone wanting to look more on it.
Yeah, and if you have any specific thoughts or ways of engagement or want to talk more, just feel free to shoot me an email or Martina an email, and we'll see what we can do.
Exciting stuff for sure.
Yeah, that was very excellent.
Great. Yeah, thanks. It's also a good, I think, a good level of understanding on your guys, because obviously you guys are involved in the semantic technology, so it's a little bit easier for you guys to comprehend. But happy to hear. Yeah.
Yeah. Excellent. Well, hopefully we'll try some of this out. You know, I think we have a few clients that could be candidates.
Yeah, if you need any support around that, or you feel like you would like to demo something but don't know how to, reach out, and we can set something up.
Yeah. Excellent.
Okay.
Thanks much. Okay.
Very good.